have a look at balancing half equations. And we're going to start off here looking at some simple examples. And they're considered simple because they contain only one element in the half equation. There's going to be two basic rules we follow. Firstly, we need to balance the number of that element on both sides of my half equation. And secondly, we need to balance the charge. And the way we do that is by adding electrons to either the left side or the right side of the equation. So let's take an example. Here we go. Here's an example of an oxidation half equation in which I can see a bromide ion is becoming molecular bromine. So the first task is to balance the element, or bromine in this case, on both sides. I can see on the left there is just one bromine, whereas on the right there are two. So a simple first step, I'm going to add a big 2 on the left, which balances the number of bromines on each side. Secondly, I need to balance the charge by adding electrons to one side of my equation. In order to work out which side that is and how many electrons I need to add, we first need to calculate the total charge on each side of the equation. So currently on the left side I've got 2 bromide ions which each have a negative charge. So the overall charge on the left is 2 negative. On the right side I've just got a nice neutral molecule of bromine which has no charge. So the charge on the right side is 0. So where am I going to add electrons? Well, adding electrons to one side is going to decrease the total charge on that side. So I'm looking to add those electrons to the most positive side of my half equation. In this case, it would be the right-hand side, which has 0 charge overall. And by adding 2 electrons to that side of the equation, the overall charge on the right side has now dropped down to 2 negative, which is equal to the left side, which is exactly what we want. Let's take a look at a second example. This time it's going to be a reduction example. I can see a copper 2+ ion being reduced to become copper. So again, first of all I need to balance the elements, and in this case I've actually already got 1 copper on both sides of my equation, so I don't need to change anything. And secondly, I need to balance the charge on both sides of my half equation. So let's again work out the total charge on the left at the moment, which would be 2 positive charges from my copper 2 positive ion. Whereas on the right, I have elemental copper, or effectively a copper atom with 0 charge overall. So on the right-hand side, we can say that the total charge is 0 at the moment. And then again, which side am I going to add my electrons to? Well, I want to add them to the most positive side in order to decrease the total charge to equal the opposite side. So in this case, I'm going to have to add 2 electrons on the left-hand side, which now cancels out those 2 positive charges, giving me a total of 0 charge on the left, which is equal to the right. And both of those are balanced. As a quick check, we can always work out if we've put the electrons on the right side, because if I identify where in my oxidation half equation, oxidation is the loss of electrons, meaning the electrons should appear on the right-hand side. They are being lost or kind of released. Whereas with reduction, which means a gain in electrons, I should have electrons being added on the left-hand side. So that's a helpful quick check. Let's now have a quick look at some more complex examples. And these are more complex because they contain more than one element in the half equation. So in this case, you'll see on the left, we've got some slightly more complicated rules, and you'll notice also that to balance these complex examples, we are either carrying these reactions out in acidic solution or sometimes in basic solution. And this means that to balance my equation, at some stage I will be able to add water to one side, and I will also be able to add H plus or OH minus to both sides because we have an acidic or a basic solution. So let's, to start with, have a look at the oxidation half equation at the top, where my sulfite ion is becoming a sulfate ion. So what am I going to do first of all? Well, we need to balance the interesting element, and we're kind of ignoring oxygen or hydrogen at this stage. So let's look at sulfur first of all. And I can see I've got one sulfur on the left of my equation and one on the right of the equation. So that first step is complete already. For step number 2, I can now balance the oxygens by adding water to one side of my equation. And given that I've got 3 oxygens on the left and 4 on the right, I'm probably going to need to add one water molecule to the left-hand side, which is going to give me 4 oxygens in total, which is equal to the oxygens on the right. And once I've done that, you'll see we've now introduced some hydrogens into my equation. So step 3 is going to be to balance those hydrogens by adding H pluses on the other side in order to have the same number of hydrogens. So I've got 2 hydrogens from my water molecule, which means I'm going to have to add 2 H pluses on the right hand side in order to balance those. And then finally, if I'm doing this in acidic conditions, you'll see there is a 4th step, which is similar to our simple examples, and I need to balance the charge by adding electrons. So again, we're going to calculate the total charge on each side. We need to be a little bit more careful because there's a few more things in our equation here. I can see a water molecule, which is neutral on the left, and then the sulfite ion, which has 2 negative charges. So in total, on the left, I've got 2 negative charges. On the right-hand side, I've got the sulfate ion with 2 negative charges, and then I've got 2 positive hydrogen ions as well. So they're actually going to cancel each other out, meaning the total charge on the right is 0. So again, I can add electrons to one side, and I need to add them to the most positive side, which would be the right-hand side in this case, in order to balance or become equal to the charge on the left. So in this example, I'm going to have to add 2 electrons to the right-hand side, which would make the overall charge on the right-hand side 2 negative, which matches the right-hand side. Now, for one further step, if you are doing this in basic solution, we know in a basic solution, actually, we're not going to have H pluses floating around. We're likely to have OH minuses or hydroxide ions. So the simple step we're going to take now to cancel out the H pluses on the right hand side of my equation, I can add hydroxide ions to do so. So if I, for example, add 2 hydroxide ions, they're going to react with the 2 H plus ions to form 2 water molecules. But if I've done that on the right hand side, I also need to do that on the left hand side. And then I can simply add everything together on both sides and present that again as a full half equation. So in this case, we've got SO3 2-. I've got my water molecule. I've now added 2 hydroxide ions. And then moving to the right hand side, I've got my sulfate ion. The 2 H pluses have reacted with the 2 OH minuses to become 2 water molecules. And I've still got my 2 electrons. Now, because we've added 2 hydroxide ions to both sides, the total charges on both sides will be the same still. So let's now have a look at the reduction example. In this case, I've got the dichromate ion being reduced to become the Cr3+ or chromium 3+ ion on the right hand side. So step number 1, balance the interesting elements. So again, we're ignoring O or H at this point, and we're going to focus on chromium. I've got 2 chromiums on the left side and just 1 chromium on the right hand side. So I need to add a big 2 on the right hand side to balance the number of chromiums. Next step, to balance the oxygens by adding water. Well, in total on the left, I've got 7 oxygens, which means I'm going to have to add 7 waters on the right hand side. My oxygens are now balanced. Step 3, balance the hydrogens by adding H+. Well, I've just added waters on the right. I've got 7 water molecules, which would be a total of 14 hydrogens. So on the left hand side, I now need to add 14 H pluses. And finally, if we're doing this in acidic solution, I need to balance the charge in my half equation by adding electrons. So let's work out the total charge on the left and right and work out where we can add them. On the left at the moment, I've got the dichromate ion with 2 negative charges, and then I've got 14 H pluses. So in total, I've got 2 negatives, 14 positives, which means overall I'm going to have 12 positive charges on the left-hand side of my equation. On the right side, I've got 2 chromium 3 plus ions and then 7 neutral water molecules. So actually in total on the right hand side, I've currently got 6 positive charges. So the final step then is to work out where I need to add electrons, and I'm going to add them to the most positive side, which is the left side, and I'm going to need to add 6 electrons in order to reduce that total charge from 12 plus to 6 plus, and then we have equal or balanced charge on both sides. And for the final step, if you were doing this in a basic solution, again we simply need to add OH minuses or hydroxides to cancel out all of the H pluses by forming water. So because I've got 14 H pluses on the left hand side, I'm going to need to add 14 hydroxide ions to the left hand side, and if I do it to the left side, I must also do it to the right side. So again, in this case, I can now write that full half equation out again. I've got the dichromate ion. I'm going to have 14 waters when those H pluses and OH minuses combine. 6 electrons are still there. And then on the right hand side, 2 Cr3 plus. I've got my 7 H2Os, and I've now added 14 OH minus as well. And that's pretty much it for balancing half equations. There's lots of different examples you can practice on. Hopefully this video was of some help.